Hi guys, can you see it?
That looks good, Juan.
Awesome. Here everyone, I'm Juan. I'm the curator of birds at Oakland Zoo. Thank you, Gabby, and thank you, Don, for inviting me to be here. And thank you everybody for attending. I'm going to be sharing with you some of the results of my the PhD research. I study at Texas A&M under Don. I was his first PhD student, and I should have claimed credit just for that. But my research was focused on parrot nutrition. It was quite a few years ago, but I believe it's still the results are still relevant, and I hope you find them interesting. So the first thing, why parrots and why nutrition? I guess is a question that it doesn't need much explanation in this forum. And my slide is not moving.
Click on the actual screen itself. That may help get it. There we
Okay,
go.
no, I don't know how. Anyway, as everybody knows in this call, parrots are one of the most endangered orders in the world and the most endangered in the neotropics. And in nutrition is really important because it helps us understand its survival and productivity, but also to implement conservation measurements. And in captivity, it has application in improving the husbandry both for conservation aviculture as well as for commercial aviculture. Like Romy was explaining, the wild parrots are herbivores mostly. They have a sort of different plant materials, but also they feed on insects. And as Don also mentioned, they also use some of the species, they feed on soil, they feed on clay licks. There are quite a few diet studies of wild parrots out there. However, they are all qualitative. There's not really quantitative. There's not much quantitative data. There's not really nutritional wild parrot studies as many as the species. Why is this? And also Romy again mentioned it. It's pretty difficult to quantify just by direct observation what the birds are eating in the wild. They usually feed in the canopy of the trees. They are highly mobile. It's not easy to observe them. They have a wide variety of items in the diet. It's not the same thing to see that is eating on one fruit, that what particular part of the fruit, what the level of ripeness the fruit has, all that will have an influence on the nutrition. And then there will be always missing items, things that we don't realize that they're eating. So there has been a few extrapolation nutritional studies for parrots based on observations, but there's very little information out there. Parrot hand feeding is a very common avicultural practice. It helps both in boosting production and sometimes in the survival of some chicks that the parents are neglecting. It's also used as a taming tool for the parrot trade. It's important to consider that the high neonatal level of parrot chicks and that being fed by regurgitation, having a crop that makes a uh, particular case for hand feeding. We know a bit of the requirements for the growth of parrots, and that's based on budgeriggers and cockatiels, which are pretty much seed eaters and are not really the full representative of the whole order of parrots. And we know also that there's a lot of trial and error in the hand feedings, and many times they're based on the poultry nutrition. Most of the poultry nutrition is really well studied. We have a lot of science behind poultry, but they are being fed to maximize its growth. They are not fed to for a healthy longevity, and that means that sometimes it's not applicable. Not only that, but the physiology and the ecology of chickens and parrots is pretty different. So, what are the challenges when we hand feed parrots? The first one that we usually find is that the parent fed birds they have a higher growth rate than the hand fed. We are not sure what is exactly why this is happening, but we know there are some physical aspects of the feeding. We use formulas which are basically powder in suspension in water, and that creates problems with dehydration and the passing rate, as is not the natural consistency that the birds will have in the wild. We have also issues with fermentation and crop sour in many cases. Then there's sorry, there's also quite a few nutritional limitations for hand feeding, and as Don mentioned, we still have vitamin deficiencies. There's also mineral deficiencies. We have just general lack of energy, and this has a whole series of endogenous components like enzymes and probiotics that we are probably missing from diets. Second. And then we have what people call difficult species, which in my experience is not that they're more difficult than others, it's just that we don't know what the requirements are. So how can we study more about the nutrition of parrots, especially the baby parrots? We chose the method of crop sampling. So it's taking a direct sample of the crop of the chicks. This has some advantages, like being able to have a direct sample of the diet composition and the nutrition. It's not affected by digestion like it will happen if you use fecal samples or stomach samples. And also we get a whole sample of the whole diet that is accumulated in the crop. What are the cons? Usually we have a really small samples because the parrots don't have that much food inside of them, and also the size of the chicks, the age of the chicks limits which ones can be sampled. Crop sample had been used before for nutritional studies of skull macaws by Don, and also here in New Zealand it had been used before for the kakapo. So how we do crop sampling usually is lubricated tube, plastic tube of different sizes according to the size of the chick that is introduced in the esophagus to the crop, and at that point, we take a sample from the content. The protocol is to do it only with the birds are more than 20 days old and no more than once a week. The problem, as I said, is that the sample that you can get is pretty small. In my case, of all the samples, most of them, once they were dry for analysis, they weighted less than 1 gram every sample. So it's very limited what you can do with such a small amount. Before my study, this method was used, but for qualitative diet studies, to know the composition of the different items in the diet, but it was not used for nutrition, except for the kakapo and the macaw. So when I work with Skull macaw from a species from the rainforest, as you know, from the south of Mexico to the north of Bolivia, and the samples I got came from Chambopata Research Center in Peru, where the Don has a really long-term monitoring program. This is a species that has been reported to eat more than 73 plant species, and as Don mentioned, is also feeding on clay leaks. I had samples of 23 chicks from 3 seasons, a total of 112 samples. Then the red green macaw, another Ara species, also for the rainforest in the Amazon basin, also samples from Chambopata. This one, the diet is a bit less diverse, 56 species identified, and also using the clay leaks. I work with samples from 6 chicks, 3 seasons, a total of 33 samples. It's not as many as the macaw, the skull macaw. Then I work with in the Bahamas with the Cuban or the abaco parrot from the island of Abaco. This is a very specialized habitat. It only lives in the dry forests of the coast of the island, and is near threatened. One of the most interesting aspects of this species is that they nest in the ground. There are limestone cavities, and instead of using the trees, by being an island without predators, they evolved to nest in the ground, and it's really, really shocking to put your hand in the ground and pull a chick. A parrot chick is something that you usually don't expect. There has been some breeding diet studies before done in this species, and they identify 18 species of plants they feed on. I did only 1 season for this species, but I sampled 27 chicks, a total of 35 samples. Then in Mexico, in the west of Mexico, the lilac crown Amazon, it's a dry tropical forest species. I got samples from the Chamela Cuismala Biosphere Reserve. It's a vulnerable species, and it feeds on 33 plant species, including some insects too. I got samples from 2 seasons, 33 chicks, and a total of 95 samples. Last but not least, the thick-billed parrot, the Rhicopsita pagrinca. It's a very specialized feeder from the pine forests of the Sierra Madre Occidental in Mexico. Used to be in the States. The only one of the two species of parrots that used to be in the States, but is not found anymore, and is considered endangered by the IUCN. As I said, is a pine seed specialist. It moves around the landscape, like Don was saying, following the different pine species fruiting. We sampled 32 chicks. It's over 2 seasons, a total of 34 samples. So what I did with the samples, first in the field, they were classified. Like in that photo on the top right, you see, we split them in different components as much as possible. Sometimes it was possible to identify the components. Many times we didn't know what they were, especially with the ARA species, which had a very diverse diet. Then they were photographed and measured, and they were frozen. Back in the States, I dried the samples, and as I said, every sample, the weight of each of them, it was really low, so I had to do some pooling, meaning I mixed samples from the chicks from the same nest taken the same day, and in some cases also chicks of similar age, even if they were not from the same nest, of course, between the same species. And then in the lab, we ran the approximate analysis, the mineral, the amino acids, and the fatty acid profiles. At the same time, I studied what at the time was the main 15 hand feeding formulas in the market in the States from 10 different brands. You can see them here in the picture. And I ran the same nutrition analysis as in the crop samples. And I also made essay to measure the time that they were able to remain in suspension, as well as some experiments to understand the volume needed to provide same energy depending on each of the diets. I didn't work with like most other studies as in a percentage of dry matter, in a dry matter basis, but I did it on a metabolic energy basis, and this is because being diets of different caloric content and between different species is not really applicable when what the bird will be eating is based on the energy density of the food. And here you have an example. Let's say that we have diet A with 10 megajoules of energy per kilogram, and diet B with 20, so one much energy than the other one. If the requirements of if the requirements of the bird in particular is 20 megajoules per day, then for one of the diets it will be eating 2 kilograms. For the other one, will be eating 1, in order to get to the same amount of energy at the end. If we calculate the requirement of calcium as percentage of dry matter and said that it was 1%, then that means that in the first case, it's going to be eating 2 grams of calcium in that day because it's eating more food. And the other one is only going to be eating 10. However, if we do this in a metabolic energy basis, the requirement will be the same, and the amount eaten of calcium will be the same in both cases. It will be 10. So this is the reason why instead of dry matter, I use a metabolic energy basis. So enough of this, let's go into the results. This is the first one. This is the time that the formula was able to maintain in suspension. You here have the percentage of solids on the Y, and this is the percentage of solids. This is the time that I measure for 3 times after preparing. And you see, like, of the 15 samples, most of them, even after 30 minutes, it maintained close to 100% of all the solids in suspension. But there was 5, and mostly 3 of them, which even after 15 minutes, they start really separating, and you didn't hold all the solids in suspension. Then I look at the dilution effect of the diet. So I play with skull macaw with 42 days, that it was approximated 100 grams. That bird, based it on, sorry, I have an issue with the, it will have a requirement of energy of 1.14 megajoules per day, meaning that depending on what diet you use, using all the manufacturer specifications, it will require between 175 and 345 milliliters of formula per day, depending on which formula you use. This again is based on the specifications in the bag. Why? And that volume of food, it should be possible to feed in 3 or 4 times per day, which is will be the rate that you can fill the crop of a bird of that age. However, if you have a younger bird, only 86 grams, and this will be its metabolic energy needs. Depending of the formula that you use, it provides you, and following the instructions of the manufacturer, it provides you a range between 40 and 174 milliliters per day that you would need to feed it. That is between 5 and 20 times per day, based on a 10% maximum amount of food, 10% of the body weight per day. And that's basically not possible. A chick of that age, he won't be able to process more than 6 to 8 times feeds per day, meaning that 40% of the formulas, they are not really able to provide the amount of energy that this chick will need. This is just highlighting how the energy density of some of the formulas is not adequate for the higher needs of the smaller chicks. The more into the diet, this is the examples of what the crop content. The top one here is the skull macaw. This is the red and green macaw. This is the abaco parrot, Leyland crown, and this is the thick bill. As you can see, both areas have really big chunks of food, and there are big beans and seeds. There's also some bark. Here in the abaco parrot, you have poison ivy, some fruit, and these are pine seeds. For the Leyland crown, they are all small seeds. And for the thick-billed parrot, there are pine seeds and also some bark. In the table, I put it all on the table. The skull macaw, the green macaw, we found both seeds, fruits, barks, insect, and soil. I will talk about the soil next. The abaco parrot, the same, except for the soil. Leyland crown didn't have any fruits, neither the soil. And the same thing for the thick bill. Talking about soil, believe it or not, the one in the right is the crop content of one of the skull macaws in Tambopata, and all that brown stuff is no more than soil. On the left is a similar sample from another chick at the same time. It was not fed any. Sorry, somebody was talking. No, it was feeding no soil. So calculating the ash content, the mineral content of these samples, we found out that the skull macaw samples have a range between 4 and 53% of dry matter, which is really high. The plants that they consist, the plants that the macaws eat in Tambopata, there was a previous study that said that in average, they have around 6% dry matter of ash, meaning that anything about that percentage, it will be coming from the soil. For the red green macaw, it was even more. It was between 6 and 86% of the sample. 86% of the sample was ash, and this 80% is equivalent to potting soil. So they were eating really, really, really soil. These guys. So I had to remove the samples with soil from the analysis of both the other species of both macaws, because it was just not possible to run the analysis with such a high mineral content. That would underestimate the mineral content of these samples. Also, we know that most of that soil is really not absorbed, so it's not really available as mineral nutrition. So starting with the results for the nutritional part, here you have the predicted metabolic energy of the diet, which is here the different species. As you see, has quite a big range between the crops, between 17 to 27 megajoules per kilogram, with the thick-billed parrot, the one being the highest. In contrast, the hand-feeding formulas, it was in the lower range. It's only the same as the skull macaw. It was below any of the other species. As a comparison, we have here the requirements for chickens of similar age. And just for fun, I drop here the energy found in the crops of the kakapo, which is one of the birds with the lowest metabolic basal metabolism. So it has a really exceptional low amount of energy in the diet. Then with the minerals, calcium, it gives quite a interesting range from zero point 0.2 to almost zero point 0.6. With the all the formulas, providing enough calcium to cover the needs of to just to match up what it was in the crop of all the species. The poultry, this is the requirements of poultry, which are higher, which it makes sense, being a species that is growing much faster, but probably not a good representative of what the parrots need. The proportion of calcium phosphorus, which is very important for the absorption of the first one, we see that the hand feeding formula has a medium value and has quite a big range. In fact, the red and green macaws and the skull macaws, both of them have a level similar to the poultry, which is pretty high considering that the requirements should not be that much, but it's a big range. Then sodium, which is its deficiency will produce a reduced growth, and is one of the explanations for geophagia, as Don mentioned first. Is the explanation for why they are selecting different clay leaks levels, with different concentration of sodium. Here we find that the Cuban Amazon has a much higher, more than 5 times higher sodium than any of the other species, which makes sense considering that it's a coastal habitat, and there will be a lot of the sea breeze bringing salt into the environment. For the both macaws, the scarlet and the red and green, as I said, these samples are without soil, so we will be expecting to have soil in the diet also, which is not accounted in these samples. What is surprising and is interesting of this finding is that neither the lilac crown, neither the thick bill seems to be eating that amount of soil of sodium, and makes you question, if the driver of the geophagia, it's sodium just as a nutritional, or for another reason, like because these two are not don't seems to need it. This is the hand feeding formulas, which is a much higher, even that the higher one, which is the Cuban, and the poultry once again, exceeds the levels on the crops. Magnesium, really important for enzymatic reactions and for many physiological processes. What we found is that all the species have a pretty similar level, except for the thick bill, which apparently has a much higher level than any of them. However, neither of the hand feeding formulas even reach the lower level of found in the crops. So that's really interesting and something to keep in mind. Then the macronutrients, we have the crude fat. This it's important as a source of energy, but it's not a requirement per se for fat. But it's really obvious how the hand feeding formulas, neither of them even get close to the level of fat found in all the crops. Again, the thick-billed parrot has a higher fat level of fat content than any of them. The rest are pretty much the same. There's no significant difference. But the hand feedings fall really low comparing with that. As I said, there's no requirement for fat per se, but there's a requirement for some of the fatty acids. And to look at the fatty acids, we're going to use this type of chart. It's called a ternary chart. So you have 3 axes, and because the multi-unsaturated fatty acids, the saturated fatty acids, and the polyunsaturated fatty acids, they all 3 add to 100, because it's the 3 ways of classifying the fatty acids. You can use these graphs, and this is an example of how it works. So in here, for example, this sample in here will have 50% of saturated fatty acids, okay, following this scale, while it will have 40% of multi-unsaturated, and the rest, the polyunsaturated, will be 10%, and that gives you a total of 100, in this proportion. So this is not only for showing you the amounts, but also to show the proportions of things that add to a total of 100. So remembering that, if you look at this graph, it's a bit complicated graph, but bear with me. Let's first focus on the letters. Okay, all these letters in here, those are different oils. which I chose because they are part of the manufacture process of the foods, or because they are used sometimes by breeders to supplement food and hand feeding formulas. I also added two palms that are used for the by the leaders macaw and the hyacinth macaw, the akuri and the bacauia. They are the ones in here, these two. So here you see how there's some of them, like the palm ones, they're very heavy on saturated fatty acids, right? They fall in this area of the triangle, while some of the ones up here, the which it will be the sunflower oil, the olive oil, and the macadamia oil, they are low in polyunsaturated and low in saturated fatty acids, but very high on monounsaturated fatty acids. And last, you have a few in here, like, which are these? The walnut, the soybean, and the corn oil, which are heavier on polyunsaturated fatty acids and lower on the other two. So that's just to give you a bit of the space distribution of different oils. Then the next thing will be the hand feeding formula. So the polygon in black, the dotted line in black, and the center black triangle, that's where the hand feeding formula saturated fats fall in. You see, like for saturated fatty acid, they have between 10 and 40, for multi-unsaturated between 20 and 50, and for the polyunsaturated between 80 and 50. So these give you a really nice space of the formulas which fall all in this space. And last, all these polygons of colors, each is one of the species. And in blue, in red, I have make another polygon of the averages. So it's a really niche, really close space where all the all the parrot crops fall into. And it will be a much narrower one. It will be 10 to 30 saturated fatty acids, 20 to 40 multi-unsaturated, and 40 to 65 of polyunsaturated. Next in the protein is the constituents of tissues, enzymes, hormones. Growing birds will have a higher demand of protein for especially for tissue accretion. In here, you see is that it's not such a big variation between the different crop, except for the thick-billed parrot, which has a lower crude protein value than the rest. And the hand feeding formulas, all of them are providing above what the level in the crops are found. Then similar to with the fats, the protein per se, there's no requirement of it, but there's definitely a requirement for the essential amino acids, the 10, 12 essential amino acids, depending on how you count them. And here you have, then I'm comparing all the parrot crops in gray with the requirements of chickens, which are really well known, just to see how they match. We see how arginine, the requirements of poultry are lower than what it was found in the crops. That doesn't mean that this is the requirement of parrots. That means it could be that they are being fed more what they need, but it gives you already an orientation of how they compare with the requirements of chicken. Similar with proline, if the levels in the crops are above of what is found in or what is used in the poultry industry. And then we compare the crops samples with the hand feeding formulas. You get this. Each of the colors is one of the species, and the gray bars are the total hand feeding formulas. You see, like for two in particular, arginine especially and valine, all the crop samples have higher values than what the formulas provide. And there's only one thing, that is the proline, where all formulas are above the levels found in the crop. The rest are pretty good match, but definitely arginine and valine, there could be a potential limitation or deficiency because none of the formulas provide as much as found in the crops. I'm getting there. Then if you look at all the macronutrients as in one and balance, it's using the same kind of graph.
Good to see you. What are you doing here?
Using the same kind of graph with the fat here on the bottom, the crude protein on the right, and the rest, the carbohydrates and the ash on the right, on the left. You see the handwritten formulas again is the black polygon with the average in the triangle. So you see it's a really narrow between below 10 to 20% of crude fat, all the crops. Oh, sorry, all the hand feeding formulas, between 15 to almost 40% of protein. There's more bigger range of protein in the formulas, and the rest will be the carbohydrates and the ash. Then that compares with the space that the crop samples fall into, which is all the color polygons. And in here, I put together all the averages except for the thick-billed parrot, which it really stands away with much higher fat, especially. The protein is very similar, but the fat is definitely much higher in the thick-billed than in the other ones. And these other four are really similar. It's one of the most interesting findings of this research, how these all different species convey in the very same nutritional space. This takes us to something that I won't have time to talk about more, but also Don mentioned, it's about the nutritional regulation, how the birds know what to eat. There's two general theories. One is the optimal foraging theory, which basically says that the food intake is driven by the energy content. The other one is the geometry of nutrition, which says that it's different nutrients which they simultaneously interact, and the birds, what they are looking for is to meet that target. It will be similar to this. With the different nutrients, they get to the same targeting here. So it seems definitely from these results, that the geometry of nutrition theory will apply for this study. So getting to conclusions, there's definitely not much consensus between manufacturers for hand feeding formulas. We saw that it was all over the place. However, for the Ara and the Amazonas species, seems that the one single formula will probably cover pretty well all the different requirements. It will match up pretty well with what we found in the crop samples, except for the thick-billed parrot. The thick-billed parrot had a much higher metabolic energy and fat, which this could be related to the higher energy needs of thermoregulation. They nest in a much higher altitude, no a tropical place like all the other four species. So that could be the reason why the chicks need a higher metabolic energy, and the fat could be the source of that energy. Definitely there is a space to evaluate if increasing the crude fat in the hand feeding formulas, the magnesium, the arginine, and the valine, has a positive effect on the growth on the health of the birds. This seems it's a big opportunity for the manufacturers to look into this. Also, is this space for improving the capacity of maintain the solids in suspensions for some of the samples. And we see how for the smaller chicks, most of the formula, 40% of the formulas that we analyze, didn't have a higher enough density of energy density in order to provide the needs of the younger birds. So just one single formula. I think I'll talk about that later. So from the free living nutrition point of view, what we learn is that even with different habitats, different diets, different weathers, at the end, all the birds are able to get to feed the chicks a very similar nutrition, again with the exception of the thick bill, but the rest of the birds seems to be able to forage selectively and to complement different ingredients to reach the same nutritional values, and this is really interesting. We found in some species, especially in the scarlet macaw, quite a range on the values of the crop samples, of the nutritional values, and this is what it tells us, is that they probably use a lot of complementary feeding. There is obviously not single food that provides all what they need, but is the addition of different and the complementation of different ingredients which provide the final nutrition. And then the poultry seems not be the best model for suggesting nutrition, especially if following the nutritional requirements of poultry, we will be falling into excessive protein, calcium, phosphorus, and sodium nutrition in parrots. Then the sodium, the diet, I believe that that requires more thought, especially in those species which are not known of eating soil. How can it be that they don't need it, or why they don't need it? It may be not just for nutritional purposes, but it may be playing other roles in in the diet of the species who ingest the soil. If anybody has interest, there were 4 papers coming out from this research in which you can dive in and get many more details. And with this, I only have to acknowledge my graduate committee, as well as all the colleagues and friends who helped me getting these samples and went through the thesis. The staff of the Schubert Center also helped a lot, and I am very grateful to them. That's for me. I don't know if there's time for questions.